Steve. I'm with a company called Erlang Solutions, and I'm here to tell you a little bit about Erlang. I'm here to answer Grumpy Cat's question, which is, what the heck is an Erlang? Well, in short, it's a programming language. Language designed to solve this particular problem, which is how do you keep thousands of telephone calls going 24 hours a day without anything going wrong? Like, when is it allowed to have your 911 service to be broken? The answer is it's never allowed to be down. So the answer to this problem turned out to be a programming language, which we now call Erlang. Let me tell you a few things that people find interesting about Erlang. Something that's unique to the Erlang language is hot code swap. If you need to fix a bug, add a feature, you do not have to turn the system off. You don't have to reboot it. You can load in new code and keep running. It does not have to stop. Erlang is built with a let it crash philosophy. In other words, instead of assuming your programmers are geniuses and that nothing will ever go wrong with your programs, it assumes that, yeah, things are going to go wrong. And instead of everything having to be perfect, let's recover from failure gracefully so that, again, the system never has to stop. Erlang programs are succinct. If you compare an Erlang program to something that's equivalent in Java or C++, the Erlang program will have somewhere between 4 to 10 times fewer lines of code. And what does that mean? Less code means less bugs. Less bugs means less testing. Less testing means your programmers spend more time doing things that are actually important to you, writing code that needs to get things done. So you get more done in less time. Erlang is open source. No license fees. You can download it and start using it tomorrow. You're free to customize it. Erlang language, also cross-platform. Pick any Linux you happen to like. Windows, Mac OS X, runs on embedded platforms. And you can compile it from source if you're that kind of person. Also, Erlang is very mature. It's been in production out in the world for more than 20 years. It comes with an extensive set of libraries and design patterns so that you can build your application in a scalable and reliable way. Speaking of scalability, it's one of Erlang's very biggest strengths in that your application will scale across multiple cores inside your servers and across multiple nodes across the network. And why is that important? Well, as some of you probably know, individual CPUs are not getting as fast as they used to be anymore. So what we're doing is buying more and more CPUs. Standard programming practices means that just because you have 4 CPUs doesn't mean you get 4 times the performance out the other side. You actually have to program in a new way. And Erlang is part of a family of functional languages that many of you might have heard about before, including Erlang, Haskell, Scala, Clojure, and F#. Have anyone heard of those things before? All right. Nerd score. Also, something new in the Erlang world is a language called Elixir, which is essentially Erlang, but with a Ruby syntax. Who here programs Ruby? Just a couple people. Rubyists like it because they don't feel like you have to learn a whole new language to learn Erlang. It's actually created by the people behind Ruby. What's different about it? It adds metaprogramming and polymorphism. And if you know what that is, give yourself a gold star. Okay, Steve, so that's great. Where is this Erlang stuff used? Erlang is powering systems in banking, e-commerce, gaming, lots of games use it, messaging, telecom, voice over IP, NoSQL databases. Basically any place where you need a system that has to be scalable, has to be fault tolerant, has to be up and running every day. For a lot of places, they will come in and replace an existing part of their system that's a bottleneck. Could be Java, could be Ruby, something that isn't quite fast enough. Erlang could be a solution there. Of course, it's not the right tool for everything. Just use it where it works. Oh, and so who in particular is using Erlang? Has anyone heard of WhatsApp? Yes, they sold to Facebook for $19 billion. Yes, they are all Erlang behind the scenes. And so who else? Here's some names you've probably heard of. T-Mobile, HP, Ericsson, Nokia. Lots of big companies are using Erlang. So let me tell you a bit so that's about the Erlang language. Now my company is Erlang Solutions. We've been in business since 1999, headquartered actually in London. We have offices in Stockholm, in Krakow, Budapest, and Zurich as well. And we're opening one here in the Pacific Northwest. I work right here in Portland. What we do for our customers is we help them put Erlang to use inside their businesses. We do custom programming, we do consulting, we provide support, You can call someone if you're having trouble with your Erlang installations. Training, certification, and conferences. Our core focus is to help you reach market as fast as possible, build you a system that's the lowest lifetime cost while achieving extreme reliability and true scalability. If any of that sounds interesting to you, love to talk to you. Come find me. Questions?
Give me examples.
Of customers or?
Yeah, piece of code on the screen.
Now, I do business development, so I could pull up some Erlang code for you, but I wouldn't be able to do it within the amount of time we have.
What is it about the structure of Erlang that makes it so much better at running in parallel? Since, I mean, there have been a tremendous number of languages which all aspire, of course, to greater parallelizability. And simply saying it does it and everything scales linearly, that's the Holy Grail. What is it about Erlang that allows us to achieve that?
Well, I'll do my best to answer your question, but I'd be happy to follow up in more detail later. A lot of it has to do with the actor model. It breaks everything down into smaller and smaller pieces, and so that each individual piece is only talking to one other individual piece, and state is passed via messages. Data is also immutable, so you never reach a point where two pieces of your system is waiting to lock a particular piece of memory. A lot of little things like that, and I can discuss that more in more detail or point you to some other resources that would explain it better than I can, since I'm not an engineer.
You mentioned actors. What relationship to Akka?
Akka is part of Scala, and I know a little bit about it, but not a whole lot, so I can't really. I could be happy to answer find someone who can answer your question better and get back to you later.
Yeah, I just wondered if there was any variance that Erlang was involved in that camp, or if it's all Scala. Any variance of
Yeah, well, Akka is part of Akka is part of Scala and Java, so.
So you mentioned hot swapping of the code, not having to bring the system down, unlike compiled languages. So I was just wondering, how does that really work? So, if you're running something and it has to be up 100% of the time, so if you write your code in a way that you can actually pull out a piece of DB.
Okay, so if anyone didn't hear, the question is, how the heck does that hot swap code thing work? So the first thing to understand about it is it's complicated. It's not something that's necessarily going to do straight out of the box. It's difficult to build, but it is actually achievable. There are telephone switches out there built by Ericsson that run Erlang that have been in continual operation for 10 years without downtime. As I understand it, and again, I'm not an engineer, the way it works is since Erlang breaks everything down into these tiny actors, what you do is you construct your application in such a way that when it's time to rotate the code, as it were, you slowly have to age out the old ones and bring in the new ones and manage state so you don't screw up. So if you've got a piece of code that's still running the previous version, the data it has, the system has to be constructed so during the hot swap you don't lose that state and all those things that are going on there. So until that dies off because its piece of work has been taken care of. And then the next time that function is called, you get the new one. And the trick is managing that sort of transitional period between part of the system's running the old code and part of the system's running the new code. Does that help?
Yeah, so it's kind of like a highway, where you might have two ways to get to the same place, perhaps.
Yeah, for a period of time you've got two ways. You just make two ways to get to the same location. You just got to make sure that all the cars that are on the old highway get off before you demolish it and just have the new highway.
It sounds like you just put the new code behind the old code until it runs course, and then it stays its place in the routine.
Again, I'm not an engineer, so I'm not 100% the right way to do it, but
When you say highway, it sounds like, okay, well, one gets on, one gets off.
yeah, it's something like that. Yeah, you retire the old code one process at a time until all the old code is gone.
I think the thing that people are drawing on is that it can be done instantly, and the reality is you kind of have to pave the path before you can follow the road.
Right, you have to build the system in such a way that it'll work that way, and it's extra work. Not every installation would you want to do that, but when you absolutely positively have to keep it up 24/7, it can be done.
All right, thank you very much.
Thank you.